Okay, so you guys, today we're dealing with special right triangles. Your note page is a bit different today, but you grabbed that on the way in, and I have this picture on there for you so that you can reference that and take some notes right below it. Okay, special right triangles. So as you go through geometry, you use the special right triangles a lot, and then when you get to advanced algebra next year, at the end of the year, I mean, you see up on my backboard, we don't call it advanced algebra, we actually call it trig, but you don't actually do the trig part of that course until the end of the year. So really, all year you're doing what's in most school districts is called Algebra 2, the second year algebra, or advanced algebra. Okay, I know in our school district we call it Algebra 1-2 is first year algebra, which is kind of weird. And then here we call it trig, or advanced algebra class, Algebra 3-4, which I've never heard called that any other place other than Lake Stevens. That's only because we're special. Okay? But second year algebra, this skill, this concept of special right triangles is a building block of trig. Okay, when you're dealing with the unit circle and sine, cosine, and tangent, and you're talking about the different special angles within the unit circle, you're dealing with the 45/45s or multiples of the 45, and your 30/60s or multiples of those. So this is a huge piece for you to understand. Just like this yesterday when I said, hey, you had simplifying radicals in algebra. We're going to quickly review it, but I expect you to know it. This is you have special right triangles you've dealt with in geometry. When we get to advanced algebra next year, we get to that section, I'm going to say, look, this is a review of geometry. Okay, we're going to do a quick review. Now I expect you to know how to work with them. So get that foundation laid right now. Okay, make sure you're asking a lot of questions. Okay, so special right triangle, if I have a 45, 45, 90, and I actually want to, my goal in this is to use these properties to make dealing with the Pythagorean theorem much easier when you have these special right triangles. So what I'm going to do is I'm going to look at this triangle, and I'm going to recognize that it's what type of triangle? It is right. You are right. Okay? What else is it? Emma? It's an isosceles. This side is congruent to that side. We know that because those base angles are congruent, so the sides opposite to them are also congruent. Okay? If that's the case, and I say that this side length right here, CB, if I call that a length of x, that means that AC it's also x. Okay? And what I'm going to do is I'm going to use the Pythagorean theorem to find out this length right here. Okay? For now, let's go ahead and just call that length, we'll just call it y. Okay? But I want to find this length. If this is x and this is x, let's find y. So what we're going to do is we're going to use the Pythagorean theorem. A squared plus b squared equals c squared. Okay? I am actually solving for this length. All right? Everyone with me? What is a? X. So that's x squared. What is b? X. So that is, that is also x squared. And c we're calling y. Okay, I want to solve for y. Okay, so we got y squared there. So we want to know what that is. So on this side of my equation, how many x squareds do I have? 2. 2x squareds equals my y squared. Everyone agree? Okay. Now, if I want to get y by itself, what do I have to do there? Cameron? Yeah, I got to take the square root. Yeah, I got to get rid of this squared. So we got to take the square root. And so we're taking the square root of the whole thing. So the square root of 2x squareds equals y. Is everyone with me? Okay. Now, question is, now that we know that this equals that, question is, can I simplify this? Yeah?
You can take an x out.
I could take an x out. In fact, root 2 times x squared is the same thing as root 2 times root x squared. You can break those two pieces apart. All right? Which means, as Haley said, we could take an x out. The square root of x squared is just x. So this is same as having root 2 times x equals y. Now that's usually not how we write that. We usually put that piece in front of the root. The radical is the back part. So I'm just going to switch those around. We can multiply in any order. So x root 2 equals y. So this side, if these two lengths are x, this side is x square root 2. Now think about the benefit there. Oh, go ahead, Bethany.
So we would just like write it like that if it was like asking a question like that?
Well, the benefit of this now is if I give you a problem and that looks something like, say this guy right here. Find the value of each variable, leave your answer in simplest radical form. Okay, so if I gave you that problem right there, and I know that this is a 45, 45, 90. Now, how do I know it's a 45, 45, 90? Maggie?
Because the two sides are equal to each other, meaning that the angles are equal to each other.
Good. Yeah, if these are congruent, that's isosceles, that's 90. I only have 90 to split here. Both these have to be 45. So it's important to know, okay? So if we have this and we know this relationship right here, if those are the same, in this problem, what is x? Not this x. Okay? If you think of our special right triangle, our 45, 45, 90, where we have, it's a really bad drawing. Oh my goodness. Let's try that again. Okay, where I have x, x, and x root 2, in this picture, this length is our x, right? So if that's 7, that's equal to x. This is 7, that's equal to x. This x right here is called actually x root 2. So that length right there is x root 2, so that means this is actually 7 root 2. Okay, so that's the benefit of knowing this relationship. Otherwise, what you're doing, I'll get you in a minute here, Cameron. Otherwise, what you're doing is the Pythagorean theorem. You're going, well, I know this, and I'm trying to find that. So I'd have to go 7 squared plus 7 squared equals, in this case, their x. And then that's 49 plus 49 equals x, which means this is 190, this is 98 equals, sorry, that's x squared. And then I take the square root of 98, which is x, and then I simplify that to 7 root 2. This is much faster if we know that relationship. That's the goal here, is that we can quickly find those values. That answer your question? Yes? Maybe?
Yeah.
Cameron, question?
Does that apply to all 45 degree triangles?
Applies to all 45, 45, 90s. Yep. Okay, how many think you got it? Let's try this one then. Give me a number. I heard 6. That side's 6. I want you to solve for the other sides. Done? All right, good. Once you solve, tell your neighbors. Okay, time's up. What's this then?
6.
6, and what's this?
6 square root 2.
Okay, that's why you like special right triangles. They're easy to deal with. Okay, how many got those? All right. Now, it can't always be that easy, right? We always have to make it a little more complex. There you go. There's that one now. Solve for x. Leave your answer in simplest radical form. Talk with your neighbor how you're going to do that. Here's what you know. You know that in a special right triangle, that your relationship is, and I tell students when you're doing this, just write it down real quick. You know that. Okay? And so as you're working through it, It may take a little time, and you may find it a lot easier if at the very beginning you go, hey, this is a 45, 45, 90. I know that because these sides are equal, meaning these have to be both 45 because you're splitting the 90 that's left over. Okay? And so from there, when you're dealing with a 45, 45, 90, if you just look at the general form, this side is x. This side is x. This side is x root 2. Now what you're looking for is you've come up with 3 different equations there. Everyone see them? Here's an equation, here's an equation, and here's an equation. Can I solve this?
No.
It's infinitely many, right? We can't actually come up with a value for x. Can you solve that? Can I solve that? Yeah, it's one variable, one equation. So what I'm going to do is I'm going to take this, and I'm actually going to do the math for it. I'm going to say, well, x root 2 equals 7. How do I get x by itself? Okay, now some of you would square it. Now that's a valid way to do it. Okay, so if you squared both sides, I'll work through that way first. Now that's not the way I generally do it, but that's not the way I learned it. So you could square both sides. If you square both sides, let's make sure we understand that when I square this side, this is not 49 or 7, it's 49. This side's 49. This side over here, you're squaring 2 things. You're squaring that and that. So you have x squared equals, or x squared times 2. Root 2 times root 2 is root 4, which is just 2. So whenever you square a radical, those pieces cancel and you're left with what's inside. So here you're left with 2x squared. Now what do I do? Divide by 2. Yeah, x squared equals 49 halves. Now what do you do? And now you'd have to take the square root, right? Okay. So that becomes x equals root 49 halves. Now it's poor form in math to leave a fraction under a radical. So you've got to break that up. That's root 49 over root 2. Good, which is 7. That's a perfect square over root 2. It's also poor form in math to have a radical in the denominator. You can't do that. That is not being, your radical is not rationalized, is what we call that. So you've got to multiply by what we call a special number 1. So x equals, if I have 7 over root 2, to get rid of that root 2 in the denominator, I've got to multiply by root 2 over root 2. Now what is root 2 divided by root 2? Let's just look at that for a minute. What is that? It's 1. When you multiply by 1, do you change the value? No. It doesn't change. So the value of this isn't changing by multiplying here. It's just the form of it's changing. So this now becomes 7 root 2 over, what's root 2 times root 2? 2. A root times itself is like squaring it, right? Root 2 times root 2 is root 4, which is just 2. Whenever you multiply a radical by itself, you get the thing inside. This is your answer. 7 root 2 over 2. Now I will tell you, I would not have started by squaring it.
Nope.
Okay? I would have started by saying, sorry. I would have started this problem with x root 2 equaling 7. Okay, that's what we had here. I would have started by dividing by root 2 to get x by itself. That ends up giving 7 over root 2. Now that brings you right to here. It's like skipping ahead. You know, if you're playing a game and it says, hey, go directly to go, collect whatever, or go, if you're playing Sorry. You guys have, do you know what board games are anymore? Yes. I'm just wondering. All right. Huh?
We're talking about Monopoly.
Yeah, I know, but then sorry, you can go directly to your, bring a pawn to home or go back to start. Don't go back to start, that's bad. But you can go, whatever. All right. Yeah, you can switch places. All right. So at this point, now I multiply by root 2 over root 2, which saves you a little time. That gives you x equals 7 root 2 over 2. Okay? Yes?
So what happens if, like, when I notice on the homework where it's like x would be, like, if you had z, like if the 7 was a z, and then, okay, number 7, there's a radical 2 as one of the, like, x, per se.
Right here?
How would you, like, plug that in, like, radical 2, radical 2?
What is radical 2, radical 2?
No, what she's saying is the two legs.
The 2 legs.
Mm-hmm. Right. I know what she's saying. So you're saying like you have a root here. So let's say that's root 3.
Yeah, like what if you have values like
And that's root 3, and this is x root 3. Or right, root 2. What's root 3 times, so you plug, this is your x, right? So you plug that in right here, you end up with root 3 times root 2. What is that? That's root 6. So this side becomes root 6. Okay? Now be careful on the one you're saying. If you had a root 2 there, that's root 2 times root 2. What's root 2 times root 2?
2.
That is 2. Okay? Anytime you multiply a root by itself, you get the number inside. Okay? It's like squaring it. All right. Other questions on the 45? Yeah? I don't want to ask questions on the assignment.
No.
Okay.
But just as an example, so like for this one, the one you gave us on your example,
Yeah.
using the 7.
Yep.
What if it comes out as like just a regular number?
Then it's a regular number. That's okay.
Like
Yeah.
you don't have to go fancy putting over stuff.
Nope.
Okay, sounds good.
All right. Hey, guys, this is learning math, right? It's not learning shortcuts and tricks. Okay, I'm not into that because then you have this big bag of shortcuts and tricks that you have to try to memorize. So you have to like somehow become a magician in your math class, which isn't what we're into. All your rules that you've learned in math so far can apply here. So what I want to do right now is I want to talk about 30, 60, 90s. Okay, so here we've got it. 30, 60, 90s. A 30, 60, 90 triangle, so this on the other side of your note page. A 30, 60, 90 triangle really is half of a triangle that looks like this. Now if this is 60, and this is 60, and this is another 30, which makes this entire thing 60, what type of triangle is this? What is it, Jocelyn? Yeah, it's equilateral. Okay? That means this side equals this side, which equals this side. All three sides are equal. Which is good because that means if I know that this side right here, AB, is the same as CB, then when I erase this, DB is what part of AB? It's half. Okay? So DB, this length, is half of this length. So because we're not big fans of fractions, it's easier to deal without them. I love fractions. I have them over for, Friday night, just hang out. Okay? We watch half a show. Okay? So AB and DB, this length, I'm not going to call X. I'm going to call this 2X. Which means, where is X? Tell your neighbor. All right. Ethan, where's X? Yeah. If this is 2X, this length is half of 2X, or X. Now, if we use the Pythagorean theorem, we should be able to find out AD. I want you to right now use the Pythagorean theorem to find this length. All right. So I know if I once again call this I'm going to call this y, just so I can reference it. I would know that x squared plus y squared equals 2x squared. Now, some of you may mess up right here, forgetting that this is a leg, so it's this squared times this, or plus this squared equals that squared. If you made that mistake, just make a note of it. Okay. Some of you may mess up right here when you actually square 2x squared. You got to square both parts, which is actually 4x squared. And if I have 4x squareds, that means I have 4 little x squareds running around. And I take away an x squared. How many little x squareds are left? There's 3 x squareds. Okay, you're just counting them. I had 4. I just took one away, and now I'm left with 3. Y squared equals 3x squared. Now, I don't want to know what y squared equals. I want to know what y equals. So what's my next step? Take the root. Square root of 3x squared. Now I can break that root apart to be root x squared times root 3. And root x squared is actually x root 3. So this length is not y anymore. We're going to call it x root 3. The benefit there, now I just have x's. If I know x, if I know one of these sides, I can solve for all the others. So your special right triangle for a 30, 60, 90. Here's your relationship. Shorter side's x. Hypotenuse is 2x. The longest leg is x root 3. So you have 2 special situations now. So, yeah.
I got the extra 3 answer even with the mistake that you said earlier.
You did what? You got that even by making the mistake?
I did 2x squared plus x squared, which you said was wrong, but I still got the same.
So you made a mistake and then maybe made another mistake which counted that mistake. Yeah. Yeah.
Okay, so how would you find the values if they gave you like a value not x? Okay, like if they gave you y.
Why don't can we progress through that? Like I have a progression that I wanted to take. I like have that one, and then I have that one, and then I have that one, which will hopefully walk you through it. Okay? So, find the value of each variable. Leave your answer in simplest radical form. All right, so here's the first one. Once again, the first thing you need to do when you're dealing with these triangles, if you're learning them, if it's a 30, 60, 90, just quickly, and you only have to label one of these, if that's 60, okay? The shorter side's x, longest side's 2x, this one's x root 3. So you now have your quick template to reference. I would just, anytime I'm dealing with special right triangles on the top of the paper, I just do a quick sketch. All right, so in this, x corresponds to x. That's good. Y corresponds to x root 3. So I label them, and 2x corresponds to 12. Which of the 3 equations can I solve? 12 equals 2x. It's the only one with a single variable that I could actually solve. This one has 2 variables. This one is infinitely many. If x equals x, yay, we know that. But we know how to solve this. If x equals 2x, what is x? It's 6. And once I know x, I can now solve for y. Y is 6 root 3. We plug 6 in for x. We now know y. We know this x equals 6. So the key when you're dealing with these, if you label the sides based upon our 30, 60, 90 relationship, it makes it easier. Any questions what I did there? I want you to try this one, please. Okay? Label it, right. Copy it down, label your sides. All right, what do we call this side right here? 2x. What do we call this side? X root 3. And this side? X. So which one can we solve? Well, that one's solved for us. We know x equals 12. Just plug that in. This is 12 root 3 and
24.
now it's kind of weird because we put that x in and they say they're calling that x, right? So like this is our x. So you know, if you want to make it a special, another letter or something, maybe your letter, like your name, maybe I would call it M for McCoy. I don't know. All right. Otherwise, it could be confusing seeing x here and x here. You know what I mean? Okay. It's two different x's. Any questions on it? So this would be like our special x special version. All right, try that one. Last one together today. Okay, what are we calling this side right here? That is x. X equals x. What's this one? X root 3. What's this one?
2x.
2x. So the hard part is when they give you, the hard part's where they tell you what your root equals sometimes. When your side x root 3 equals something. The thing that I would hope that eventually you guys do, or you're able to see the pattern involved. If you have 12 equals x root 3, I know the answer right now. Like I know the pattern here. Okay? So the first thing I'm going to do is divide by root 3 on both sides. So I get 12 over root 3 equals x. And then to get rid of that radical, I need to multiply by what? Root 3 over root 3. So I'm going to multiply that by root 3 over root 3. Okay? When I do that, I end up with what on the bottom? 3. And what on the top? 12 root 3. Okay. Now before I go any further with that, how many can see the pattern going from here to here? So I'd hope if I said, now this is a completely different problem, I'd hope if I said, hey, 17 equals x root 3, that you would be able to just go, hey, that right there is 17 root 3 over 3. Right? You just, whatever's in here becomes your bottom, and this piece gets attached to that on top. Mathematically, what's happening is this. Yes?
Okay, so after you do that, define,
Okay, pause for a minute. Are you talking about on this?
yes.
Okay, so can you do this? Yes? Okay, so before we go there, 15 root, actually, let's go 18 equals x root 3. Okay?
18 root 3 over
Okay, so how many have it? All right, so it's 18 root 3 over 3 equals x, right? So, Bethany, what's your question off that one?
Well, okay, not off of that, I guess. I guess that's the next.
No, I'm pretty sure. If
My question.
what's your question?
Okay.
What's your
Would you always have to find the next side, like to multiply that by 2? Would you just multiply everything by 2? No.
no? Wait. We'll get to that. What can I do here? Yeah.
With the 2, get rid of the, you have to divide the 18 by 3 because it cancels out.
Yeah, you have to reduce there. If this whole number goes into that whole number, you have to reduce. This becomes 6 root 3. Okay? So on this problem, the one we're currently on, we have one more step there. Everyone reduce it. Okay, what is it?
4 square root 3.
4 root 3. We reduce just the fraction piece, right? The whole numbers. 12 divided by 3, 4 root 3. So Bethany's question now, if x equals 4 root 3, we're going to put that in right here. We put that 4 root 3 in for the x, and that equals y. So 2 times 4 times root 3 is 8 root 3. You don't distribute into both parts. You only multiply the whole number, please. Okay?
And so the bottom would be,
This would be 4 root 3. Yep. Yes?
Okay, so what if you had a situation where you didn't simplify it because it couldn't be simplified anymore?
So, like if you had to double, I don't know, 6 root 3 over 2. Oh yeah, you can. 6 root 3 over how about over 7?
Can't simplify it.
Okay, how do you multiply that? Yeah. Yeah, this is just a fraction right here. 2 times 6 is 12. Root 3, 1 times 7 is 7.
Oh,
Okay? It's just that's just doing fractions, right? Multiplying fraction, which we're all pretty good at, I hope. Okay. So, our assignment, take a look at your assignment. Your assignment is all but example 3. All except example 3, and do not cross example 3 out. We'll be doing it tomorrow. So everything except example 3.
Even on the mixed side.
Yep. Even on the mixed side. Now, just so that you're not confused, because generally we start this assignment here in about 2 minutes. I have every student, well, not every student, but majority of the class going, I don't understand. These are squares, man. We just did the whole thing was about triangles. We had to do squares. Okay. Now, a triangle is, check it out, dude. We now have a triangle. I'm not saying you guys were going to do that, just in case. And that triangle, if this is a square, the triangle that I form in a square, all sides are equal. So when I cover up half of that square, what type of triangle is that? Hopefully that helps you out a bit. Make sure you read directions. Sometimes they'll tell you to leave it in simplest radical. Sometimes they'll tell you to round to the nearest whole number, tenth, or hundredth. For those of you that don't know what a tenth is, in decimal form, how many zeros are in the number 10? 1, right? So that's how many numbers you have to have behind the decimal. In this case, 1 number behind the decimal. So if I had 0, you guys can't see that. If I had 0 point, that is the nearest tenth. Okay, whatever, a number, 1 number behind the decimal, because there's 1, 0, and 10. How many zeros are in 100? 2. So 100, TH, okay, that's 0.0 some number, or 2 numbers behind the decimal. Maybe it's number. Okay, one of those numbers might be a 0. 2 numbers behind the decimal. Yes?
Okay, 4 on the first 3 on the example side, would you actually solve the radical instead of leaving it in radical form?
Are you talking about these?
Yeah.
Yeah, dude. You got to round it to the nearest whole number, tenth or hundredth. Yep, that's what that means. Okay. Good lucketh. Make sure you're asking questions.